This is an example of how to find an exact value of an angle that's not on the unit circle using a sum or difference identity for a cosine function in trigonometry. So let's first talk a little bit about how to find the value of 11 pi over 12 and then how to represent it as a sum or a difference of the angles on the unit circle. The easiest way to think about 11 pi over 12 is to convert it to degrees. We're a lot more used to working with degrees than radians. So if we convert it to degrees, it's just 180 on the top and pi on the bottom. The pi's will cancel out, and then if you just multiply 11 by 180 and divide by 12, you're going to get that this is 165 degrees. Now it's very easy to see that 165 degrees, if you break it up, you can represent it. This is not the only way to do this, but this is just the one way to do it. You can represent it as 120 plus 45 degrees. From the unit circle, you can see that 120 degrees corresponds to 2 pi over 3, and 45 degrees, of course, corresponds to pi over 4. So this would be 2 pi over 3 plus pi over 4. So our original angle, 11 pi over 12, would equal the sum of these two angles. Now that we know how to break it up, we can use the sum identity for cosine to actually rewrite the original statement. So cosine of 11 pi over 12 will become cosine of 2 pi over 3 plus pi over 4. We're going to open it up based on the formula for the sum of two angles for cosine, and that would be cosine of 2 pi over 3 times cosine of pi over 4 minus sine of 2 pi over 3 times sine of pi over 4. Now you can use the unit circle to complete the rest of the problem. So instead of cosine of 2 pi over 3, we would go to the 2 pi over 3 on the unit circle. Cosine is the x value, so negative 1/2 is what goes in for cosine of 2 pi over 3. Now cosine of pi over 4, pi over 4 is right here, cosine is the x-coordinate, so square root of 2 over 2. Minus sine of 2 pi over 3, so that is this y-coordinate of 2 pi over 3, so that would be square root of 3 over 2. And sine of pi over 4, that's the y-coordinate of the pi over 4 angle, that's square root of 2 over 2. Then to completely simplify the expression, you'll have to multiply the numerators of the first function, negative 1 times square root of 2, that's negative square root of 2. Multiply the denominators over 4, minus square root of 3 times square root of 2, that's square root of 6. Multiply the denominators over 4, and then rewrite it as a single fraction. So the numerators on top and a common denominator on the bottom. This would be the exact answer to this problem.